So I thought I'd record this video and show you how to conduct some different types of sampling that I want you to do. So the first kind of sampling I want you to be able to do is, well, not a random sample, but a convenience sample. It'd be nice if I could spell this word. So a convenience sample is just that. It's you take the first group of people that come in the room, or the first 10 cars that go through an intersection, or the first 10 batteries that come off an assembly line, and they're biased. They're not statistically sound, but you see them used all the time. So if I want to do a convenience sample, well, actually probably should tell you. So this is an activity that I use in my Oxbow class. Let me see if I can't zoom this in. I guess I can't with a video playing. So each one of these squares counts for 100 people. This is some town somewhere, and they've got the neighborhoods or different districts, they call them, labeled off by different size. So District 1 is a population of 400 people. District 2 is a population of 100 people. District 4 only has 300 people in it. And what we're going to do is we want to estimate, I mean, I don't know how big this town is. I don't know the population of the town. So what we're going to do is we're going to conduct certainly the 4 basic kinds of samples. I'll have to think about the cluster sample. So I'll show you how to conduct these kind of samples, and we'll see how they compare to the true average, which I do know. So the convenience sample, let's keep it easy. Let's just look at, I'm going to look at the first. I want to do samples of size 4 is usually what I do, right? Size 4. So I'm going to go with town 1, 2, 3, and 4. I mean, that can't get any more convenient than that. So that has 400 people in it. Town 2 is 100 people in it, or District 3 has 100 people in it, and District 4 has 300 people in it. So if I find the mean, I don't know if it's a little, we'll look at that next week more so, but to find the mean, remember you add up all the numbers you have and then divide by how many you have. So I'm seeing 6, I'm seeing 900 people total, divided by 4, well, I think that's 225. So the convenience sample gave me an average of 225 people per district, and if there's 40 districts in the town, 225 times 40 is, let's see, 0, 20, you guys probably can do this in your head, I can't, isn't that 1,000, or so isn't that 10,000 people? So I think there's 10,000 people in this town based on that convenience sample. So that's our estimate. So that's convenience sample. They're biased. Before I leave this, the other kind of convenience sample that I really want you aware of, because you see these all the time. There's a voluntary response sample. And what a voluntary response sample is, it doesn't really apply to here, so I can't show you how to do it here. But a voluntary response sample is a survey where people choose to respond. You call up a phone number, or maybe a better example is they go to some website and fill out a poll. There's all kinds of, I know Bill O'Reilly used to have on Fox News, he used to have maybe he still does, I haven't gone to his website since we found more stuff came out about him, but anyways, this is supposed to be political, but he has a voluntary response sample on his website where surveys, they ask people questions about things happening in the news, and he publishes results. Voluntary response sample, and the trouble with voluntary response samples is usually people with strong opinions are the ones that respond, and usually it's people with strong negative opinions. So that's why you really can't trust a voluntary response sample. I mean, use it, you can report them out, but to make any kind of inferences or draw any conclusions, you don't want to use that. And people do all the time. Okay, so then the next kind, and this is like the gold star, the gold standard kind of sample. It's a simple random sample, and you're going to see me, and you'll see many materials referred to as an SRS. And these are the primo. If you can get a simple random sample, we know how simple random samples behave. So if we have a simple random sample, or even a more or less simple random sample, we can use them all kinds of things to do. Right? Use them all kinds of inference. This is what we want, and we can't always get it. Sometimes a simple random sample is not the best kind of random sample to use too, because you're trying to get a sample that represents the population that you're sampling from, and sometimes the trouble with a simple random sample is I could, for this town, I could draw a sample, and because it's totally random, all 4 of my towns could be towns with four populations of 400. Well, that's missing. It's a random sample, and it would be a number, but we're missing all of these towns with 1 or 2. So, sometimes you need to tweak it a little bit. And we'll talk about that a bit with stratified samples. So simple random sample. Everybody needs a number. Each individual needs a number. Each individual needs a number. And well, they've already numbered them for us, so that's nice. And then you're going to use some kind of random number generator. And the reason you want to use a random number generator is because we as humans cannot generate random numbers. We always introduce some bias. Okay, I mean, if you asked anybody to pick 4 numbers from 1 to 40, I'll highly doubt that they would go 1, 2, 3, 4, and that's a possible sample. Granted, that's not any better than, well, maybe it's not any. I mean, it's no worse than what we got, but at least this is random, and we know how random samples behave. This convenience sample, who knows with that? Somebody else could get totally different, and this could be totally different. But at least there's a random selection, and that's what we want. So what I did is, your graphing calculators, if you have one, do a random number. If you want to use that, I guess you can barely see that, can't you? The random number generator in your calculator will do it. There's also this website, random.org, and somewhere here we go. I use the random.org website to generate 4 random numbers. I select the random integer generation, and I can show you. If you can't figure that out, I can certainly show you how to do that. And here's what it told me to pick. It told me I said I want to pick 4 numbers from 1 to 40, and it generated these 4 numbers. These are randomly selected. So let's go see what they are. Let's see, town 16 is a sample of, town 16 has 200 people in it. Town 39 has 100 people in it. Let's see what's the next one. Town 20 has 300 people in it. And town 26 has 100 people in it. So if I find the average of those 4 towns, or town districts I guess they are, 3, 5, 7, and the average of 700 divided by 4 is, let's see, what's it, half would be 350, and half of that is 175. Is that right? I think that looks right. 175 times, yeah, that should be right. So times 40 is, let's see, I should grab a calculator, 28, 30, 4, 7. So this estimate says there's 7,000 people. What was my convenience sample? My convenience sample said there's 10,000 people. This is much more interesting when you have a class of 20 people and they're all generating their averages. You can start looking at the distribution of these guesses and these estimates. Let's see, this is the SRS. But just me doing this, so I guess we can't do that. All right, so I've done convenience sample, simple random sample. I guess let's go ahead and do a, no, you don't want to see that yet. Sorry, pretend you didn't see that. Let's do a systematic sample. Sometimes drawing a random sample just doesn't work for you, but you can you can do a systematic sample. And what a systematic sample is you have a system, really. And what you do is you pick a random starting point. And then you skip every third, every fourth, every 10th, depending on your sample size, or depending on your population. You skip the same numbers every time. So if I started at town 5, and then I looked at every fourth town after that, that would generate, and I would do that until I got to my sample size of 4. I could do start at 5 and do every 10th, but then I'd probably have to repeat. And then what happens if you run out of numbers, you start back at the beginning. Sometimes that messes up. You just don't. You run out of numbers, and you got to change your way you do things. You can also let a random number generator pick how many you skip being your starting point. I think just so this video doesn't become 2 hours long, I think I'll just go. I think I'm going to go with my original one. I'm going to start with the 5th town, and I'm going to skip every 4th one, or go every 4th one. So where's my city here? Here it is. So what did I just say? I said start at town 5. So town 5 has a population of 200. So then if I add 4, I'm at town 9, or district 9. And district 9 has a population of 400. And then I'm going to add 4 to that, so 13. So district 13 has a population of 100. And then let's see, I'm going to add 4. So district 17, I probably should have gone with the bigger number because I'm missing 40. Well, it's okay. 17 has a population of 100 again. So we found the average of these. That's 6, 7. So 700 divided by 4. That again, is that 175? Feels like I've done this before. Yes, I did. It's the exact same thing. So what was that? That was the average, which was 175, and my estimate of the population was what? 175 times 40. So again, 7,000. So not much different between my simple random sample and my systematic sample, and that's just the luck of the draw, the way I drew that. Okay. So we've done convenience, we've done simple random sample, we've done systematic sample because we're making a system, and that's how we pick our numbers. I guess the last one, well, we get 2 more kinds of samples to go for, so maybe I'll try to. Let's do the stratified sample. So it's called, the fancy name for this is a stratified random sample. I should have had these already for you. Okay, and what you can do is you're going to break your groups up into strata or into groups. You break up your population into strata or into groups that have some similar characteristic. Okay, that's in the book. I don't have to write that all out. So what I usually do when I do a systematic or a stratified sample for this, I usually split this up into all these towns are the northwestern section of town. This is the northeastern section of town. This is the southeastern section of town. This is the southwest part of town. And then what you can do is you can not the word, I want to say prorate, but that's not it. You can proportion your sample into, like, you see how the southeastern section seems to have a lot more people in it. Well, maybe, or a lot more towns in it. Maybe it would be good to pick. I mean, if I did a sample size of more than 4, it would be easier. But we could pick 2 here and 2 here and ignore those, or that would be sample size of 4. But again, those are getting ignored. If I did a sample size of let's see, I could do 8. I could say 3 from here, 3 from here. That would be 6. 2 from here, no, and then 1 from each of these, and that would be I'd have six towns selected. So that's the nice thing about stratified samples. You can you can draw more from one section or one strata if it has a bigger population that needs that representation. I could also have broken this up into big town districts and small town districts, I could say three or more, or 300 or 400, and then 100 or 200. See which ones there are more of, and broken up that way. I'm going to take this very easy. I'm going to take one town from each section, and I'm going to let my random number generator do this for me. So let me get a calculator here.